My revision session 2, end of term 2 final exams. And you can see now I'm gonna talk about trigonometry this time. My previous video was on circular measure, and now I'm gonna explain you trigonometry. So the first question which you see in trigonometry is we have to know how to solve the basic trigonometric equations. So these are all 6 questions which I have written in front of you. They are called basic trigonometric equations. And whenever we solve any trigonometric equation, we first look at what is the range given to us. Because every trigonometric equation has infinitely many solutions. You need to bound your solutions within the range which is provided in the exam. So here he gives you the range from 0 to 360. Before I go further in details or solving the questions, you need to understand the following things which I discussed in the class. Guys, this is called a quadrant diagram. Quadrant diagram. In a quadrant diagram, I will write this is my first quadrant. It ranges from 0 degree to 90 degrees anti-clockwise when you move, and from 90 to 180 degrees anti-clockwise. Then from 180 to 70 degrees, it's a third quadrant. This was the second quadrant. And now if you move from 270 and comes back to 0 degree after making one rotation, I can say that I have covered 360 degrees. So in this quadrant, this is called the fourth quadrant, right? So I have distributed or the angles in anti-clockwise directions. So this is my first quadrant, which contains all acute angles, and the second quadrant contains all obtuse angles, and then the third quadrant contains all reflex angles. And also now I'm gonna write the fourth quadrant, which starts from 270 and ends at 360 degree. They're also reflex angle. So any angle which falls in the first quadrant is acute. Any angle which falls between 90 and 180 is obtuse. Now you need to understand when the angle is following in the third quadrant, because it should be between 180 and 270. Same thing applies for the angle which falls in the fourth quadrant, has to be between 270 to 360. So everyone must be knowing the quadrant diagram. Another thing which is interesting in quadrant diagram, I'm going to write A in the first quadrant. In the second quadrant, I write S. And in the third quadrant, I write T. And in the fourth quadrant, I write C. So A, S, T, C. A stands for all. S stands for sine. T stands for tan. And C stands for cosine. So all positive. S means sine positive, T means tan positive, C means cosine positive. So may I explain what I want to tell? That sine is positive, yani sine gives positive answers. Sine of any angle gives positive answers. Okay. Sine gives positive answers. For outputs in first and second quadrant. and it gives negative answers in third and fourth quadrant. Clear? So sine is positive in first and second quadrant, and it is uh, negative in, let me try to open it again because there is a glitch here. Yeah. So sine is positive in the first and the second quadrant and negative in third and the fourth quadrant. Cosine of x gives positive answers or outputs in first and fourth quadrant, but it gives negative answers in second and third quadrant. Tan of x gives positive answers in first and third quadrant, and it gives negative answers in second and fourth quadrant. I have just written it for your understanding. So ASTC diagram is very important. You can call it as a quadrant diagram or ASTC diagram. Second diagram, which I'm going to draw it for you, that is called angle transformations. Acute angle, if I give you any angle in the first quadrant, so this is called angle transformation diagram. Transformation diagram. What is this? If I give you X and you want to transfer this angle to the second quadrant, so the formula is 180 minus X. If you want to transfer this angle into the third quadrant, formula is 180 plus X. If you want to transfer into the fourth quadrant, the formula is 360 minus X. So these three formulas are the key formulas for the transition of any acute angle, which the calculator gives you into the second, third, and fourth quadrants. So let's start. So you understand quadrant diagram and angle transformation diagram. Let me erase everything. First question, sine of x. Sine of x is equal to 0.9. So I'm going to check. My answer is positive. So why not? I can write here that this answer is what? Positive, positive, negative, positive, positive. This negative, and this is also negative. Positive tells you here x will be in which quadrant, where the sign is positive. Sign is positive in first and second quadrant. Cosine is positive in first and fourth quadrants. Sine is negative in third and fourth quadrant. Cosine is positive in first and fourth quadrants. Tan is positive in third, first and third quadrant. Tan is negative in second and fourth quadrants. Wow. So we understand in which quadrant we want to get the angle. So boys, first of all, you need to get the acute angle for the A part. To get the acute angle for the A part, you write shift sign So shift sine of 0.9. In the B part, you will try to find your acute angle. You write shift cosine of 0.9. In the C part, you'll write your acute angle, shift sign. Don't write the minus sign. Don't write the minus sign to find the acute angle. Just write shift sign of 0.6 because I'm interested in the acute angle, the first quadrant. The acute angle for the D part, shift cosine of 0.33. E part, acute angle, I want to find it. So shift tan 0.25. And the F part, I want to get my acute angle. So shift tan 0.44. So you guys saw that I didn't write any negative angle. Why? Because I'm interested in the acute angles. Convert your calculator in a degree mod, first of all, because my range is given in degrees. So here you go. I'm gonna convert my calculator angle mod into degrees. Now I'm gonna write shift sine or inverse sine of 0.9. Now this gives me 64.16. 64.16 degrees to the two decimal places. Let me write the other one. Acute angle for second part, shift cosine of 0.9. It gives me 25.84. 25.84. Shift sine of 0.6. It gives me 36.87. 36.87. Shift cosine or inverse cosine 0.33. It gives me 70.73. The two decimal places. Inverse tan 0.25. It gives me 14.04. And the last one, inverse tan 0.44. It gives me 23.75. 23.75. So you saw that I got my acute angles. And can I convert my acute angle into the first and second quadrant? First quadrant, my answer is 64.2 degrees as it is. And the second quadrant is 64.16 plus 1. Oh, 180 minus 180 minus 64.16. In the B part, my answer is in the first and the fourth quadrant. So your answer is 25.8 to one decimal place. And since you want to convert your answer acute angle to the fourth quadrant, 360 minus acute angle is 25.8. Next, C part, I was expecting my answer into the third and the fourth quadrant. So third quadrant is 180 plus 36.87. And the fourth quadrant is 360 minus acute angle 36.87. Now we go to the D part. We want the first quadrant 70.73. And then we want the answer in the fourth quadrant 360 minus 70.73. And the E part, I want the answer in the first and the third quadrant 14.04, and the third quadrant is 180 plus 14.04. Last part, we are expecting our answer in second and fourth. So 180 minus 23.75, and the fourth quadrant is 360 minus 23.75. Since I have explained it to you through the diagrams in the class, so here I did it directly. You can also use equation solver to get your answers. Clear, boys? So I'm done. explaining you how to solve the basic trigonometric equations. Now come to the sketches. In sketches, I need to explain you few important things. You remember the sine graph, the cosine graph, and the tan graph. Anyone who remembers in the class what we discussed, a sine graph has a very important thing, which is called a period. So we studied the period of sine graph, period of cosine, and the period of tan graphs. What were the periods? Because sine, cosine, and tan, they are cyclic functions. They repeat themselves. So every function, every, the behavior of a function repeats after some values of x. So sine x repeats itself after every 360 in degrees, or in pi's, in radians, it is 2 pi. Same thing goes for cosine. The period of cosine is 360, but in radians, it is 2 pi. The tan graph, its period is not 360, it's 180, but in degree, in radians, it is pi. Let me make the graphs very quickly. For sine, for cosine, and for tan. You remember the step of sine, cosine, and tan is always 90 degrees. 180, 270, 360. Sine always starts from the center line. The maximum value of sine is 1. The minimum value is -1. Same thing, cosine value is 1 and minimum value is -1. The stepping of cosine is also 90, 180, 270, and 360. Let me draw like this. It will help me make a very precise graph of sine and cosine. So sine starts from here, goes here, and make a complete wave. At 0, it is 0, 90, it is 1, 180 is 0, 270 it is -1, and 360 is 0. This is the sine graph. Cosine doesn't start from the central line. Cosine starts from here, the maximum. First it comes here, then we make a wave like this, and this is the cosine graph. The problem with tan graph is its step is 90, no worries about that. But at tan 90, we don't get any answer on a calculator because it is undefined. And 270 also, no answer. So when you don't get any answer, you need to draw the vertical asymptote here, here, like a barrier for the graph, because the graph cannot pass through this obstacle. Okay, so it gets closer to it. So how the graph looks like 0, it's like this, cutting at 180, and gets like this. Here you go. So the complete tan graph is formed within a range of 180 degree, but the complete cosine graph formed a complete waveform, or it repeats its behavior after 360 degree, and also sine graph from 360 degrees. I'm going to give you the few formulas. So period, when I write here, sorry, let me write here sine of bx and a sine bx. This number, which is a vertical stretch, if you studied the functions where I have taught you vertical stretch, so A is a vertical stretch, but the language here will be changed in trigonometry. So here I use the terminology of amplitude. Amplitude is A. So from the central line, your graph goes maximum A unit up and A unit down. Clear? So that when I say sine graph, behind is 1. So the wave will be formed between 1 and -1. If I'm saying draw the graph between 2 sine of x, so my maximum value will be 2 and the minimum value will be -2. If I write 5 sine of x, it means my maximum value of 5 and -5. So my sine wave will be formed between 5 and -5. So amplitude is well understood by you that it is a vertical stretch, and this is a number which is multiplied with the sine function. Second thing which is here, which is a multiple of the angle x. And this, um, in my understanding, we call it, this B is called frequency. Why I call it frequency? Because it tells you the number of waves, right? Now, how can I connect the frequency with the period? Wow. So the period is of a sine function is always equals to 360 degrees divided by frequency. I'm talking about sine and cosine. Period is equals to 360 degree divided by frequency. Suppose I am doing y is equals to sine of x. Now I want to know what is my how can I find my period? Period is 360 degree divided by 1. Okay. Now if I have y is equals to sine of 2x, then my frequency is 2. So what would be the new period of my function? My period will be 360 degrees divided by 2 because I have a number 2 here. Now my period will be changed from 360 degree to 180 degree. And it tells you, this 2 tells you that I'm going to have 2 waves from 0 to 360 degrees. I hope it clears to you guys. Whenever you get the period, you just need to divide it by 4, and that gives you the step. So if you want to find a step, step has a formula, 90 degrees divided by frequency. You can do that, or whatever the period you have, divide it into 4 will give you the step. Inshallah, more things I will tell you when I will be doing the sketching of these trigonometric functions. I'm keeping these basic functions in front of you guys. Okay, the first one is y is equals to sine of 3x. So if I'm doing y is equals to sine of 3x, first thing is my amplitude is 1. So I will be staying between 1 and -1. Right. Let me draw my dotted lines. Now 3 is my frequency. If 3 is my frequency, so I want to know my step. My step is equals to 90 degrees, not 360. For period, I write 360. So 90 degree divided by frequency, which is 3. So 90 divided by 3 is equal to 30 degrees. But if you say, no, Mr. Omar, I want to use the period formula. So, okay, so period is equals to 360 divided by frequency, which is 3. So it gives you 120 degrees. Now, 120 is the period, and you need to divide it into 4 equal parts. So 120 divided by 4 is also giving you 30 degrees. So in the calculator, if you want to write what is your starter is 20, your end is 360. What is your step? You are not going to put here your step 90 degree. Normally, if the frequency is 1, your step is 90 degree. But in this case, my step is 30 degrees. So I'm going to write here 30, and then I write 60, then I write 90, then I move on to the next one. 90 plus 30 is 120. Then I write 150. Then I write here, let me carry on, 180, then 210, then 240, then 270. Boys, carry on, 300, then 330, and then finally 360. Do you remember? I told you that I'm going to get 3 waves. So it's better, guys, draw the dotted lines. It completes the grid. It will help you to make a very accurate graph. Okay, everyone remembers sine graph starts from where? It starts from the center line. Okay, so Bismillah Rahman Rahim. From here, I'm going to start one wave. Did you see? It completes after 120 because now the period is 120. The period is not 360-degree because my frequency is 3. So the 360-degree divided by 3 gives you the period of this graph. Now let me make the 3 waves now. I'm going to use a different color. Okay, right. So this is the graph of y is equal to sine 3x because Mr. Omar got from 0 to 360-degree. I got 3 waves and the period of this function is 120 degrees. Done. Let's go to the B part. In the B part, we need to draw the graph of minus cosine 2x. Don't worry, guys, there is a minus sign at the back, but the number is minus 1. Minus 1 cosine of 2x. So the amplitude is 1. So your central line is x-axis, okay? And you will go maximum by 1 and minus 1. Now, how to sort it out? He's multiplying with minus 1. If you go back and try to recall functions, if I multiply the output with a minus sign, it tells you that your graph will be reflected about the x-axis, right? So I'm gonna, rather than I'm starting the graph of cosine of x from up, I will start from below because he is multiplying with a negative sign. Anyways, if a student says, no, Mr. Omar, I'm not understanding, then you can also rely on calculator. Okay, first of all, I need to define my period. You remember what is the frequency given to me? 2. So the period is equals to 360-degree divided by frequency. So Mr. Omar, my period is 180. So how many waves I'm going to get? I'm going to get 2 waves from 0 to 360. So my period is, you understand, 180. How can I write my step? You remember step is always period divided by 4. So when I do period divided by 4, 180 divided by 4, it will give me 45 degrees, right? So let us do the step. The step is 45 degrees. I'm ready to do my step. 45, then 90, then 135, then 180. Come on, 225, then 270, then yes, 315, then finally 360. My graph is going to be formed between 1 and minus 1. Let me complete the grid. Okay, and I'm ready to draw my graph. You remember, normally cosine graph starts from here. But now I'm not going to start from here. Since he multiplied with a negative number. So negative number tells you that the cosine graph will be reflected about the x-axis. So I'm going to start from here. Here you go. You make this one, then you do this, then you do this, and this is done. So imagine the 2 cycles I can easily see from 0 to 360-degree. That's why my period is 180. And my step, surprisingly, my step is from 0 to 45. So step in the calculator, if you want to write it, your step is 45 degrees. And here my step is 30 degrees. The 2 questions are done by me. Clear, boys? I'm going to raise these basic functions, which you already know very well. Now, suppose the examiner says, draw C, yani this graphs. Y is equals to tan of half x. Don't worry. Don't worry. You need to get the period first. Normally, the period of tan is pi. So formula is for tan. Don't write 360. That would be wrong. You have to write 180 for the case of tan, because the period of tan is 180 degrees divided by the frequency, because half is your frequency. So it tells you 360 degree is the period. The complete tan will be formed from 360 degrees the period. Let's try to draw. What is my step? Interesting thing is this, that my step is, in this particular case, when I do this, so 360 degrees is my period. So you remember that over there, I was dividing by 4, but in the case of tan, everything will be divided by 2 to get your step. Your step is 180. So I'm going to write here 180 and then 360. Yeah. So 360 degrees. Um, if I put here 180 degrees, I'm going to get what type of a thing? I'm going to get this, because one tan, half of 180 is 90, 10, 90 is infinity. So what type of a graph comes in front of me? I'm going to get a graph like this, and here it is like this. So this is the period which is 360 degrees. The step was 180. And my friends, what I did, I divide the period by 2 in the case of tan. If it was sine or cosine case, I was dividing the period by 4. So you can see now a complete tan half x is formed, um, yani where the period is shown and also the step is shown to you guys. It's not very complicated. If you have a problem, you can use the calculator. Oh, if you look at that, now he is not writing from 0 to 360 degree. He's asking you to draw this graph from minus 360 degrees. So what I'm going to do, I'm going to extend it back. I'm going to extend it back. So this is minus 180 degrees. I'm sorry, guys, because the space is less. So it will not look very symmetrical. So I'm going to draw here 180 degree. So the graph comes from here and goes down, and here it goes up. So this is the tan graph. So minus 360 to 360, the tan half x is drawn for you. Let us go to the D part now. In the D part, we have pi equals 2 sine of 4x. Now amplitude here is 2. Amplitude is 2. And 4 is your frequency. Done. So when I draw this sine graph, it should be formed between 2 and minus 2 because my amplitude is 2 and right. And my frequency is 4. So I'm going to get 4 waves from 0 to 360. How can I find my period? So period is very easy. 360 for the case of sine divided by the frequency. It tells me answer is 90 degrees, my period. Now 90 degrees divided by 4 to get your step. So 90 divided by 4 gives you 22.5. So imagine in the calculator, if you want to draw that, so you start from 22.5 and you keep doing like this. So allow me, guys, because the time is short, so I need to complete this question. So I will write here 0 to 360 degrees, and I know that I'm going to get 4 waves. So allow me to draw the 4 wave. 1 wave, 2 waves, 3 waves, and then 4 waves. Although the size of the waves are different, please bear with me. I just wanted to emphasize on that I want to make 4 waves in the case of 4 frequencies. We have that, okay? And the graph is between +2 and -2. I think for the time being, just um, you know, leave the E and F part because there is a horizontal transformation is also included, and the vertical translation is included. Maybe some other time, I will revise with you. But for the final exams, you need to concentrate, first of all, on the amplitude and on the frequency. So these type of questions are very important. Inshallah, I promise you, after the final exams, when we make another revision session, I will revise with you the horizontal translation and the vertical translations, although you have the idea which you took it in functions with me. Now, you see, again, we got trigonometric equations, and he is asking you he gave you the range from 0 to 2 pi, yani in degrees from 0 degrees till 360. But in this scenario, you see the trigonometric equations are not basic. He has done something. We find some frequency. We find some horizontal translation. Different types of yani complicated equations he have made. So we will try to convert them into basic trigonometric equations. So look at the first equation A. He wrote 3 tan of x plus 2 is equals to 5. Then I will try to make tan x as a subject. So send the plus 2 to the other side. It makes 3. So 3 cancel. I got tan of x is equals to 1. So this complicated equation is turned into tan of x is equal to 1. And I have already taught you how to solve this. Since my output is positive, so if my output is positive, it tells you that my angle x will be falling in the first quadrant and in the third quadrant. Then I will get my acute angle. My acute angle will be shift tan of 1, which is 45 degrees. And then I want to transfer the angle in the first and the third quadrant. First is 45 and the third will be 180 plus 45, which gives me 225. But these angles are in degrees. He is demanding you angles in radians. You can multiply with pi and divide it by 180. That gives you the final answer. But if you look at the B part, in the B part, he wrote sine of x minus pi over 6 is equals to square root of 3 over 2. Don't worry, guys. He has done something with the argument here, and he minus pi by 6. Don't worry. We need to just get our acute angles first, because my basic output is positive. So if it is a positive answer, it means I'm expecting the answer in the first and the second quadrant. So what is my acute angle? So acute angle is shift sine of square root of 3 over 2. When I do this, I will get 60 degrees. Now, since I get my answer in 60 degrees first quadrant, but as per the situation, I wanted to get the answer in the first and the second quadrant. So 60-degree second quadrant means 180 minus 60, yani 120. Can I say these are my final answers? No, they are not my final answers. These answers are actually equals to x minus pi over 6. So x minus pi over 6 is equals to, instead of 60 degrees, I'm going to write pi by 3. And instead of writing 120, I'm going to write here 120 over 180 times pi. Okay, so send the pi over 6 there. So my final answer will be pi over 3 plus pi over 6, or 120 over 180 pi plus pi over 6. Guys, this 120, I try to convert it into radian. That's why it is written in this form. So it will give you what, guys? 2 plus pi, so 3 pi. So 3 pi by 6. And this will give you how much if you simplify 0, 0, 2 over 3. This is 2 and this is 3. So times with 2, 4, and 5, 5 over 6. So these two solutions I have found. I need to get the value of x, not these answers which we found from the acute angle can be our answers. We have to add pi by 6 by the end. Clear? If you look into the C part, in the C part, our frequency is 2. So our output is positive. I'm expecting my answer in the first quadrant and the second quadrant. In the first quadrant, my acute angle will be 30 degrees and second angle will be 150 degrees. So shall I say these are my final answers? No. Um, um, he has done something with the angle. He gave us angle in 0 to 360 degrees, we need to define our dummy domain. Yani, I need to multiply everywhere with 2. So it gives you 2x and 720. So my domain is 720. In the previous case also, I did not find the dummy domain, but you have to find your dummy domain, which is yani 0 to 180 degree, and I need to subtract minus pi by 6, um, x minus pi by 6, and this was 2 pi, so 2 pi minus pi by 6. So I have to find all the possible angles, between minus pi by 6 to 11 pi by 6. So in this particular scenario, you guys can see now, I'm gonna I have found 30 and 150, but there are two more answers possible. How we can get more answers? We need to add or subtract 360 degrees. So 30 plus 360 will give you 390. And 150 also add 360 degree into it to get one more option and one more answer, which is coming within the domain, the dummy domain, sorry. So 360, 510. Now, all these answers which we have found, we have to do, they are equals to, basically, they are equals to 2x. We need to find the values of x. So our x will be 30 divided by 2, 150 divided by 2, 390 divided by 2, and 510 divided by 2. Once you get your answers in degrees, then you need to convert them into the radian mod, since the examiner demands your answer must be in a radian mod. If we look at the D part, he gave us 6 cosine of 3x minus 3 is equal to 0. You need to first transform this equation into basic form, send the 3 to the other side, divided by 2 will give you half. Now this looks like a basic trigonometric equation, but unfortunately, the angle is a multiple of a number. So frequency is 3. So we need to define our domain, dummy domain. So 0, this x is between 0 to 360. We need to multiply all the numbers in this inequality by 3. So this gives you this new dummy domain 1080. Now you need to find all the answers from 0 to 1080, and the process is same. Your acute angle will be what? Because I'm expecting my answer in the first and the fourth quadrant. So first quadrant will be, it will give me 60 degrees, and the fourth quadrant will be 300 degrees. No need to go back. So keep adding 360s to get more and more answers. So 60 plus 360 gives you how much? 420. Still, it is within the domain. Can I add more 360s into it? So if I do this, 420 plus 360, it gives me 780. Can I add again 360? 780 plus 360. Oh no, now I exceeded. So it means these are the only three possible angles which are coming within this dummy domain. And can I use the same procedure for the second angle? So 300 plus 360 will give me 660. And still my answer is within the range. I need to add 360 more, and that gives you 1080. And I'm sure that if you add furthermore 360, it will take you, outside of the dummy domain. So I got how many possible answers? 6 possible solutions of this trigonometric equation. Okay, so let's see the E part as well, because it has tan. So student needs to practice it more. I love to have my subjective term positive, so I need to rearrange my equation in this way. 7 minus 13 is equals to 2 tan of 4x. 7 minus 13 is giving you minus 6 is equals to 3 to tan of 4x. So minus 3 is equal to tan of 4x. Shall I define the domain? Yes. My original angle was from 0 to 360, and then I need to multiply all the sides by 4. When I do this, it gives me 360 times 4. I'm going to get 1440. Now, this is my dummy domain. Now, I need to get all possible answers when I write. You see my output is negative, so I'm expecting my answer in the second quadrant and in the fourth quadrant. Get your acute angle. Your acute angle will be shift tan. Don't write the negative sign, tan inverse of 3. So how can I get my answer in a second quadrant? I will write 180 minus 180 minus inverse tan of 3. And the second answer is 360 minus inverse tan of 3. Once you get these answers, boys, I'm 100% sure, alhamdulillah, you will have no problem to get your second answer, third answer, and the fourth possible answer. Maybe after that it stops. So you keep on adding 360 degrees and get more and more answers. Same thing applies here. And then after that, you go outside of the range. So in this particular case, maybe you guys will get 8 possible solutions of this trigonometric equation. I'm leaving the last F part. Now, I come to the trigonometric identities. You remember identity is like a formula. You have a left-hand side and you have a right-hand side. You need to prove left-hand side equal to the right-hand side. So first identity which I want to prove, cosine of 5 theta, we need to prove it equals to cosine theta minus 2 sine squared theta cosine of theta plus cosine of theta and sine power 4 theta. In the class, I have taught you the Pythagorean identity sine squared theta plus cosine squared theta, that is equals to 1. You can extract two formulae or two preliminary results out of it, that cosine squared theta can be written as 1 minus sine squared theta, or cosine squared theta if you want to transform into sine form. So it can be written as 1 minus sine squared. Sorry, it is repeated. So sine squared theta can be written as 1 minus cosine squared theta. So these two formulas are also provided in MF 19. Now, it looks harder on me to move from right-hand side to the left-hand side to the right-hand side. So what I actually do, the clever approach, it's better. Lots of terms can be easily, squeezed to get my answer, cosine of 5x. So why not? I will start working on my right-hand side to make it as a left-hand side. So this is my right-hand side, boys. The smart approach or the clever approach is I have only cosine here. So what Mr. Omar needs to do, he has to replace sine squared theta with minus 1 minus cosine squared theta. So shall I move on? Please go ahead. So cosine theta, I copy as it is, minus 2. And this cosine theta, again, I copy as it is. So rather than sine squared theta, I'm going to write 1 minus cosine squared theta. Got it? And plus cosine theta, I copied it as it is. And instead of sine 4 theta, I will write 1 minus cosine squared theta whole squared, because sine power 4 theta can be written as sine squared theta whole squared. And this square, I have written it here. Use your algebra skills. Cosine theta as it is. Can I open the brackets? So 2 cosine theta plus 2 cosine theta times cosine square theta means 2 cosine cube theta. Be careful, guys. This is algebra. Okay, plus cosine theta. Can I multiply 1 minus cosine square theta 2 times? Let me do it on the side rather than rewriting lots of things. So cosine square theta, I'm going to multiply it 2 times. So let's do it. 1 times 1 is 1. 1 times this is 1 minus cosine squared theta, and cosine squared theta, and this is plus cosine 4 theta. And this is 1. What is this? Minus 2 cosine squared theta plus cosine power 4 theta. I'm going to write here the multiplication of these two factors. 1 minus 2 cosine squared theta plus cosine power 4 theta. Be careful, boys. Now you need to open the brackets and multiply the cosine theta inside. Cosine theta minus 2 cosine theta plus 2 cosine cube theta plus cosine theta minus 2 cosine cube theta plus cosine 5 theta. Ready? So I'm going to cancel this with this. And this, everything canceled, and you're left with cosine of 5 theta. And that was my right-hand side I wanted to prove. Is it a hard question? I think if you can apply your algebra skills and the knowledge of trigonometry, identity proving is a fun for everyone. Okay, so let's go to the B part. In the B part, guys, he says 4 sine theta plus 3 cosine theta whole squared plus 3 sine theta minus 4 cosine theta whole squared. I need to prove it equals to 25. Why not? I can start from the left-hand side, open the brackets, and then I prove it left-hand side equal to the right-hand side. So this bracket, let me write it 2 times. 4 sine theta plus 3 cosine theta. Again, I multiply with 4 sine theta with 3 sine theta. Okay, same thing is written. I will repeat these two brackets in multiplication. 3 sine theta minus 4 cosine theta and 3 sine theta minus 4 cosine theta. Ready? Now multiply them. 4 times 4 is 16. Sine times sine is sine squared theta. And then I multiply this. 3 times 4 is 12. Then I have sine theta and cosine theta. Multiply them. 12 sine theta, cosine theta. And then I have 3 times 3 is 9 cosine squared theta. Imagine these two brackets are multiplied and I wrote my answer here. Now another bracket which is here, I'm going to multiply 3 times 3, 9 sine squared theta minus 12 sine theta cosine theta, and then I multiply them minus 12 sine theta cosine theta, and finally minus 4 times minus 4 is plus 16 cosine squared theta. Ready? So can we simplify our results? This result is going to be cancelled with this one. This result is going to cancel with this one. Can I combine? 16 sine square plus 9 sine square will give you 25 sine squared theta. And here 9 cosine square plus 16 cosine square will give you 25 cosine square theta. Can I take 25 common? So sine squared theta plus cosine squared theta, which is a Pythagorean identity, and that is equals to 1. So my answer is 25 times 1, which is equals to 25. So this identity is also proved. Now, there is a third identity which he is asking you, C part. He said tan square of A minus tan square of B. You need to prove it equals to sine square of A minus sine squared of B over cosine square of A and cosine squared of B. Why not? I can take my left-hand side. This is my left-hand side, and you remember the quotient identity for in AS level, sine tan square can be written as sine square A over cosine square A minus sine square B over cosine square B. Between the two fractions, I have a minus sign. I'm going to draw a big line. Cosine square A, cosine squared B down, sine squared A multiplied with cosine squared B minus sine squared B multiplied with cosine squared A. Now let me check what is the result I want to make. Oh, in the numerator, I have only sine form. So if in the numerator I have only sine form, I need to use my Pythagorean identity extracted result. What is that? Instead of cosine square of B, I will write 1 minus sine squared B minus sine squared B as it is. Instead of cosine squared A, I will write 1 minus sine squared A whole over cosine squared A cosine squared B. Open the brackets on the top, sine squared A minus sine squared B minus sine squared B, and minus will make it plus sine squared A sine squared B, and in the denominator cosine squared A cosine squared B. I'm going to cancel the results. You remember, guys, when I multiplied, I forgot to multiply with sine square. So this result is going to cancel with this one, and I will be left with sine square of A minus sine squared B over cosine square of A and cosine square of B. And this is the result which I wanted to prove. I hope everyone understood this question. Next one is, again, question number 5, I have set for you as an identity that prove that tan of theta, it is equals to this thing. I'm going to write tan theta as sine theta over cosine theta. It looks harder for me to make this result. So why not? I will try to solve the right-hand side. So I'm going to take my right-hand side, which is square root of 1 minus, sorry, sine squared theta. This is the smart approach which you should apply when you are doing trigonometry questions. So imagine sine squared theta, it is equals to over Pythagorean identity, 1 minus sine square is equals to cosine squared theta. And I write square root, and here sine of x over cosine of x square. Square cancel with the square root. I get sine x over cosine of x, and which is equals to tan of x. And that's proved equals to the left hand side. It's not hard. Now come to the B part. He said 1 minus sine square of theta over tan theta. I'm taking the left hand side, guys. 1 minus sine square theta, it is equals to cosine square theta, and tan theta is equals to sine theta over cosine theta. My friends, the cosine theta goes up, so cosine square theta multiply with cosine theta over sine theta. Multiply the two terms on the top, so cosine cube theta over sine theta, and that is my right hand side. Now come to the C part. Sine squared theta is my left hand side, 1 minus cosine theta. My friends, sine squared theta can be written as what? 1 minus cosine squared theta over 1 minus cosine theta. We cannot cancel the two factors up and down. Can we factorize it further? 1 minus cosine theta and 1 plus cosine theta. The difference of two squares formula, I used it in the numerator. Cancel 1 minus cosine theta with 1 minus cosine, and you're left with 1 plus cosine theta. Is it the right hand side, guys? Yes, it is the right hand side. Then we go to the D part. D part is 2 minus cosine squared theta whole squared, 1 minus 4 sine squared theta. We want to prove it to cosine power 4 theta. Let's try to solve our left hand side. So the left hand side, I'm going to write this bracket 2 times cosine squared theta and 2 minus cosine squared theta minus 4 sine squared theta. 2 times 2 is 4. Now this is 2 cosine square theta, and this is minus 2 cosine square theta. Minus cosine square and minus cosine square is plus cosine 4 theta minus 4 sine squared theta. Now let's see what the answer comes to us. This is 4 minus 4 cosine squared theta plus cosine 4 theta minus 4 sine squared theta. I want to get the answer in terms of cosine. So that's why we need to use Pythagorean identity. So 4 as it is, minus 4 cosine square theta as it is, cosine power 4 theta as it is, minus 4 as it is. But instead of sine square, I'll write 1 minus cosine square theta. So 4 minus 4 cosine square theta plus cosine 4 theta, open the brackets, minus 4, and minus 4 times this one is plus 4 cosine squared theta. Can I cancel this with this and minus 4 with 4? And we are left with cosine of 4 theta. Is this the thing I wanted to prove? Yes, this is the result which I wanted to make. It is my right hand side. Guys, congratulations. We are done with the book questions. Now we reach to the past paper questions. The first question which I have selected for you, it is 9709. It came in October, November 2022, variant 1. Examiner says that show that the solution, the equation, this is equation, not identity. If it was an identity, examiner could have written 3 lines, but he has told you first of all that this is equation, and moreover, he writes here equal sign. He wants to check on our algebra skills that can we transform this fractional equation into this simple quadratic equation in sine theta. So let's move on and try to see how can you apply your algebra skills. So Mr. Omer is going to use for sine theta here, for the sake of simplicity, I'm going to write sine theta as S and cosine theta as C, so that algebra question looks simple to me. So S plus C plus 1 over S minus C is equal to 1. I'm trying to simplify this. You remember, I'm going to have here S plus C and S minus C. S minus C here plus S plus C is equal to 1. And this is 2S minus, and the CC will be cancelled. So 2S will be left on the top. And here in the denominator, I have a difference of two squares formula, which is S squared minus C squared is equal to 1. Send it here. So it gives you 2S is equals to S squared minus C squared. My friends, you remember from Pythagorean identity, C squared is equal to 1 minus S squared. Yani cosine squared is equal to 1 minus sine squared. So 2S is equal to S squared. In the place of C squared, I'm going to write 1 minus S squared. So 2S is equal to S squared minus 1 plus S squared, and try to create a quadratic equation, 2S squared minus 2S minus 1. And it comes to me 2 sine squared theta minus 2 sine theta minus 1. Is this the result I wanted to make? Yes, the examiner said you have to get the quadratic equation. And then he uses a word hence. Hence means we need to use this previous quadratic equation and try to get all the possible answers from 0 to 360. Go to the calculator, since it is a disguised quadratic equation in sine theta. Go to the menu, and I'm going to look for polynomial equation. I want to solve degree 2. Enter 2, the coefficient of sine squared. Enter minus 2, the coefficient of sine, and minus 1. And what is my first answer? Interestingly, guys, I got my answers in decimal form. Let me check why this happens to me. Did I do any mistake? No, I didn't do any mistake, inshallah. This is all fine. This is all fine. Okay, go ahead. So 2, enter minus 2, enter minus 1. I got the first answer, 1.366. So sine theta, I got it 1.366. And the second answer, which I'm going to get now, guys, it gives me minus 0.366. So sine theta minus 0.366. Oh, guys, interesting thing. How come the sine answer can be bigger than 1? Because you remember sine theta in the sketches also, you saw that it is always, the amplitude is 1. It is always between minus 1 and 1. How its answer is like this. If you don't believe in me, go and write here in the calculator that shift sign of 1.366 and you get the math error. It means it's not possible. So please write here, uh, not possible, and ignore this equation. I'm going to solve this. Remember, my output is negative, so I'm expecting my answer into the third quadrant and the fourth quadrant. How can I get my acute angle? Let's go on. Is your calculator in a degree mod? Yep, it is in degrees. So shift sign, don't write a minus sign, just write 0.366 and get your degrees 21.47. So 21.47, I want to get the answer in a third quadrant. 180 plus answer 201.5. 201.5. And the fourth quadrant is, let me write here, 360 minus shift sign, the acute angle, which I found 0.366. Okay, what was the answer? I got 338.5. 338.5. You may use equation solver, guys, to check your answer is right or wrong. Now I go to the question number 2. Again, the examiner has given me to prove the identity. Identity means the left-hand side has to be proven equal to the right-hand side. So what I'm gonna do, guys, I'm gonna write my left-hand side here in front of you. Uh, may I use uh, sine theta as S and cosine theta as C? So S over S plus C over S minus C, right? I'm gonna do the fraction S plus C or S minus C, S multiplied with S minus C plus C, S plus C, got it? So open the brackets, S squared minus SC plus SC plus C squared over S squared minus C squared. Now this is cancelled and I got S squared plus C squared. Everyone remember sine square plus cosine square, Pythagorean identity, it is equals to 1. So I'm going to write 1 over S squared minus C squared. Is my answers matching? No, my answer is not matching. So what to do in this particular case? No worries. You need to stop here by writing 1 over sine square theta minus cosine square theta because I cannot proceed further. I need to write my right hand side now. Right hand side is tan square theta. Sometimes it happens the examiner give you that type of an identity which cannot easily be matched with the right hand side. So in that particular scenario, you start moving from left hand and stop somewhere, and then you start your right hand side and also start solving it. And then a point comes where both of the results will give you the same answer. So that's also one of the ways which students are using in solving the identity. So I'm going to write, uh, the quotient identity. Tan square can be written as sine square theta over cosine square theta plus 1. Okay, here sine square theta over cosine square theta minus 1. Can I multiply every fraction with cosine square theta? It's allowed in algebra. Every term I'm multiplying with cosine square theta. This is cancelled, this is cancelled. What is left to me on the top? I'm left with sine square theta plus cosine square theta. And in the denominator, I'm left with sine square theta minus cosine square theta. Guys, you remember the top is equals to what? The top is equals to, this top is equal to 1. So this top is equal to 1 over. Now, could you please look into the left-hand side over there on the top? Is it the same thing which you got? Oh, wow. So you started from your left-hand side, you ended at this place, then you thought like you are standing nowhere, you don't know how to move this answer towards the right-hand side. Then I started simplifying right-hand side, then both results were connected to each other. This is also a very, very good question. Then he uses the command word hence. So we need to rely on these results. The left-hand side is equals to tan square. Can I write here t square plus 1 over t squared minus 1? He said it is equals to 2. So start working into it and your range is given from 0 to pi. So do the cross multiplication. T squared plus 1 is equal to 2t squared minus 2, and then 1 plus 2 is equal to 2t squared minus t squared. So 3 is equals to 3t squared, and t squared is equal to 1. Am I right? No, 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 no. This is t squared, and then t is equals to plus minus square root of 3. So t is equal to square root of 3, and t is equal to minus square root of 3. Done. Your tan is positive in the first and the third quadrant. So this answer I want it in the first quadrant, because third quadrant is not given here. Look, the domain which is given to you, he wants the answer only in the first and the second quadrant. So if any option, any answer comes to you in the third and fourth, you need to discard it. And this is the answer which I'm going to get in the second quadrant. How can I make it? In the acute angle will be tan inverse of square root of 3. So I can write 180 minus inverse tan of square root of 3. Guys, I'm doing it directly because I know that you already have an idea about these type of questions. So this is, I think this will come to you, I think 60 degrees or pi over 3. You may check that. And 180 minus pi by 3, and 180 means pi. So this will give you 2 pi by 3. So two solutions you will able to get from this. Next question is also very interesting, that he gave you, how many questions left? Question number 3, 4, 5, and 6. Okay, okay, okay.